Hello everyone and welcome to Module 5 of this training course on the Internet of Things for Hydrological Measurement. My name is Douglas Nyole. This module is part of a series of modules that have been prepared for this training course. In this module, we will be building our first basic IoT system. In the previous modules, we mentioned the four main components that make up an IoT system. The first one is a sensor or the device. Then we also have the platform, the communication, and the application. In this module, we will be specifically focused on the first two, that is the sensor or device and the platform. We will be building an IoT system that takes temperature measurements. To be able to achieve this, what do we need? We first need a DS18B20 temperature sensor like what has been displayed here. We also need the LoP4 microcontroller, a computer that has Visual Studio Code already installed, and PyMaker plugin installed into the Visual Studio Code. We also need the micro USB cable that has a USB type A on one end and micro USB on the other end. For this exercise, we need the micro USB cable to be able to connect between the computer and the microcontroller. We also need this cable to be able to supply power from the computer to the microcontroller. When deploying the IoT system out in the field, we need a LiPo battery because we are not able to leave the laptop out in the field. And the way this works is that the one end of the LiPo battery connects to the microcontroller as indicated in the image. In this next slide, we will discuss how to connect the temperature sensor to the microcontroller. The temperature sensor comes with 3 wires. It has a black, or in some cases may come as blue. Then we have the yellow, and then we have the red. The black connects to the GND or the ground in the microcontroller. Then the yellow one is a data cable. This one connects to one of the pin and is used to communicate with the sensor, that is between the microcontroller and the sensor, so that the data can be transferred from the sensor to the microcontroller. Then we have the red, which is a power cable. This one is used to connect to the power source in the microcontroller. In this case, this is usually a 3.3 volt power source. Since each sensor can be addressed to a unique address, several sensors can be connected to one data pin. So you're able to connect several sensors, like the temperature sensors, to one microcontroller by placing them in different pins. But they all have to extract power from the 3.3 volt pin, and they all have to be connected to the GND, that is the ground. In this slide, we will now demonstrate how to connect the temperature sensor to the microcontroller. Remember, we mentioned that the black or the blue connects to the GND, the yellow data connects to one of the other pins, and the red connects to the power source. So in this case, we are going to connect the black, or in some cases the blue, to the GND as indicated. The yellow will be connected to P10 for our case. However, you're allowed to choose any other pin, provided you demonstrate or you edit the script to mention that pin. The red will be connected to the volt, to the power source as indicated. Once we have successfully connected the temperature sensor into the microcontroller, next we need to connect the entire system that contains the temperature sensor and the microcontroller with our computer. We do this using a USB cable, the one that has a USB type A on one end and the micro USB type on the other end. We then go ahead and start Visual Studio Code and ensure that PyMaker console is active. Remember, the terminal should be able to read the same port as a microcontroller. If there's a problem with that, you can go back to Module 2 and repeat the process as we had already demonstrated how it's supposed to be connected. With the terminal now open in your PC and the microcontroller has been connected successfully, Go ahead and navigate, use the File and Open File menu to the folder where you have stored your files. This is a folder that has been provided for you already. Once you have navigated to the folder that contains all the files provided to you earlier, go ahead and select the folder written DS18B20 temperature sensor. Select this folder and go ahead and upload it. The script will be uploaded to the microcontroller. At this level, you should be able to see the files contained in that folder. Now select the file named demo.py. Next, go and click on Run. What do you observe at the terminal? Before we move to the next step, remember to use the Control and C button to stop the script that is running from the previous exercise. Now go ahead and select the main_new.py file, which should open as you can see in this image. Next, go ahead and run this file. What do you observe at the terminal? How is it different from the previous one? By now you should be able to notice that in the previous file that we ran, temperature measurement was only taken once. However, in the second file that we ran, measurements are taken continuously, that is at intervals. Were you able to get that? If you didn't get that, go ahead and repeat the process in this exercise, in this module. While the main_new.py script is still running, go ahead and warm the sensor as demonstrated in the image. What do you observe? How quickly is the sensor reacting? That is on the terminal. That is the end of this exercise. We have now built a basic IoT system. Congratulations. See you in the next module.